Hello everyone, this is Dr. O.P. Verma. Today we will discuss the continuous random variable PDF and its CDF. So we have already discussed the discrete random variable and its PDF and CDF. So actually discrete random variable is used for the discrete numbers like number of heads in a toss or number of aces in draw of a pack of well spot cards. So today we will discuss the continuous random variable, and continuous random variable is used for continuous data, continuous sample space. If a sample space contains infinite number of possibilities equal to the number of points on a line segment, it is called a continuous sample space. So in continuous sample space means it can take any value from a given interval. Next definition is continuous random variable. A random variable whose set of possible values is an entire interval of numbers is not discrete. When a random variable can take on values on a continuous scale, it is called a continuous random variable. So that means we can take any value from a given interval, that means from 1 to 2 we can take any value, then we say the random variable is continuous random variable. Often the possible values of a continuous random variable are precisely the same value that are contained in the continuous sample space. In most practical problems, continuous random variable represent measured data such as all possible heights, weights, temperature, distance, or life periods. Continuous probability distributions. A continuous random variable has a probability of 0 of assuming exactly any of its values. Consequently, its probability distribution cannot be given in a tabular form. At first, this may seem startling, but it becomes more plausible when we consider a particular example. Let us discuss a random variable whose values are the heights of all peoples over the age of 20. Between any two values, say 163.5 and 164.5 centimeter, or even 163.99 and 164.01 centimeter. There are infinite number of heights, one of which is 164 centimeter. The probability of selecting a person at random who is exactly 164 centimeter tall and not one of the infinity large set of height so to close 164 centimeter that you cannot humanly measure the difference is remote, and thus we assign a probability to 0 to the event. This is not the case. However, if we talk about the probability of selecting a person who is at least 163 centimeter but not more than 165 centimeter tall, now we are dealing with an interval rather than a point value of a given random variable. We shall concern ourselves with computing probability of various intervals of the continuous random variables such that P, the probability P for the random variable x that takes the value between a and b, and so forth. Note that when x is continuous, the probability of x when it takes the value from a to b, this will be equal to here the probability of x when x is less than b and greater than a will be equal to the probability of x when x takes the value less than a equal to less than equal to b. This will also equal to the probability of x when x takes the value which is greater than a less than b plus probability when x equal to b. So this will be the same as this value here. The probability at one point is 0. So it is, that is, it does not matter whether we include the endpoints of an interval or not. This is not true although when x is discrete. So in the case of discrete random variable, if we uh, not include the endpoints, then the probability will be changed. So we cannot do this in the case of discrete random variable. The probability that x assume a value between a and b is equal to the shaded area under the density function between the coordinate x equal to a and b. And from integral calculus, it is given by the formula which is in the next slide. So the probability of x when x takes the value from a to b will be equal to the integral of function from between a to b, and in the it can also be represented by the area under the curve. So this will be the area when between x equal to a and x equal to b. Probability density function or probability distribution function. The probability density function f of x is a probability density function. This is also called the PDF for the continuous random variable x defined over the set of real numbers if f of x is greater than or equal to 0 for all x belongs to R. That means the value of probability function will be always greater than or equal to 0 and sum of all the probabilities will be 1. That means if we integrate the function from minus infinity to plus infinity, it will give you the 1 if it is PDF. Third probability, if we want to find out the probability of random variable x from a to b, it will be equal to the integration of function f of x between the limit a to b. Here is the example. Suppose that the error in the reaction temperature is 0 degree centigrade for a controlled laboratory experiment is a continuous random variable x having the probability distribution like this, which is x square upon 3 in the interval when x lies from minus 1 to 2. As elsewhere, it's 0. So you have to verify fx is a density function, and second one you have to find out the probability of x when x is greater than 0 and less than equal to 1. So solution is given on the next slide. So for first solution, from the definition, function is obviously greater than equal to 0. So to verify it's a PDF, we will integrate the given function from between the limits minus infinity to plus infinity. So we will integrate this function from minus 1 to 1 because minus 1 to 2 because outside the interval the value of function is 0, so the integral of 0 function will be 0, so we will not integrate outside this limits. So the integral of x square upon 3 is x cube upon 9 and apply the lower limit and upper limit. So first we apply the upper limit, that is 2, so it will give you the 8 upon 9, minus we will apply the lower limit, that will give you minus 1 upon 9. So the whole answer will be 1, so that means we can say that it's a PDF. To find out the solution of second part, we will again use the definition, the probability of x when x lies between a to b. So we will integrate this function from the limit a to b, here a equal to 0 and b equal to 1. So we will integrate this function between the limit 0 to 1. So the integral of x square by 3 will be x square upon x cube upon 9, and we will apply the lower limit and upper limit. On applying the limit, we will have the answer 1 upon 9. Next is cumulative distribution function or CDF. So the cumulative distribution function f of x of a continuous random variable capital X with density function fx is probability when capital X takes all the values from less than equal to x. That means it will sum up all the probability for the random variable up to the random variable x take the value less than equal to x. So this will be, by the definition, this can also be written as we will integrate this from minus infinity to x, and immediate consequence of the definition, this one can write here two results. The probability when x takes the value from a to b, that means the value of x is greater than a and less than b will be f of b minus f of, that means we will subtract the b value of CDF at b minus value of CDF at, and we can also find the probability distribution function PDF by differentiating the CDF if the derivative exists. Here is the example. Suppose that the error in the reaction temperature in 0 degree centigrade for the control laboratory experiment is a continuous random variable as having the probability taking this. So find the CDF and use it to evaluate the probability when x takes the value greater than 0 and less than equal to 1. So the solution is given on the next page. So for solution, so to find the CDF for x, take the value from -1 to the PDF, sorry CDF, f of x is given that we will integrate the function from -infinity to x. So for f of x takes the value less than -1, the function will be 0, so the CDF will be also 0. So for -1 to 2, we will integrate this from -1 to x. Here we will not take the upper limit as 2 because it's a continuous random variable, and for every value between 1 and 2 the probability will be different, or sum of probability will be different. So we cannot use the upper limit as a constant limit, so it will be always variable limit. So on integrating it, it will give you the tq upon 9, and we will apply its limits. So first we apply the upper limit, and after that we will apply the lower limit. So on applying the limits, we will get the CDF x cube plus 1 upon 9. So therefore the CDF is given for when x takes the value less than -1, it will be 0 because the function is 0 for x less than -1. So its integration will also 0. So the 1 and the its value from -1 to 2 is x cube plus 1 upon 9, and for x greater than or equal to 2, the value will be 1. So the commutative distribution function fx is represented, is given here. Now to find the probability when x takes the value greater than 0 and less than or equal to 1, so we will use the formula that is fp minus fp, that is f1 minus f0. So we will find the CDF at x equal to 1, and we will also find the CDF at x equal to 0. So both are value lies in the second interval. So we put x equal to 1 and x equal to 0 in this interval. So we will get f1 as 2 by 9 and f0 as 1 by 9. So on solving this, we will get the value 1 by 9. So here is another example. Department of Energy (DOE) puts the project out on bid and generally estimate what a reasonable bid should be. Call the estimate B. So the reasonable bid is limited V. So the DOE, the Department of Energy, has determined that the density function of the winning bid is this. This function is non-zero when y takes the value 2 by b, when y takes the value greater than 2 by 5b and less than or equal to 2b. Find f of y, that means you have to find the cumulative distribution function and use to determine the probability that winning bid is less than the DOI probability estimate B. So outside this limit, the function is 0. So the integral outside the limit will be 0. So we will find the CDF. So we will find the CDF for the y takes the value between these. So here we will use the upper limit, not a constant, as we have discussed earlier. So we will apply the lower limit and upper limit as the variable y. So the function is 5 upon 8b. So this will give you 5t upon 8b, and we will apply the limits. On applying the limits, we will get the answer. So when y takes the value less than 2 by 5b, the function is 0. So its CDF will be also 0. And from the interval when y takes the value from 2 by 5b to 2b, we have already calculated your CDF. So this is, and for y greater than 2b, the CDF will be 1. So to determine the probability that the winning bid is less than the probability bid B, so that means the winning bid will be less than or equal to B. So that means you have to find the probability less than B. So that means you have to find the probability up to B. So we can calculate the CDF at the point B. So this will be, and the value B lies between the second interval, that is non-zero. So we apply the B equal to y equal to B in this interval. So we will have the value 5 upon 8 minus 1 by 4, that will be 3 by 8. The exercise, your Probability function is given this, and you have to find the probability that the bottle of this medicine will have a shelf life of at least 200 days and anywhere from 80 to 120 days. So you have to find the probability for these two problems. This is the same type of problems. You have to find the probability that over the period of 1 year, a family runs their vacuum cleaner less than 120 hours between 50 to 100 hours. So you can solve easily. These are the references from where we have taken the study material. You can take the help to study more. Thank you everyone.